Hi, my name is Philip. It is my great pleasure to be here today for this talk. I'm from professor from Shenzhen University in China, and today I will talk to you about algorithms to discover interesting patterns to improve the design of intelligent systems. So I will talk about data mining. How can we analyze data to find patterns that are interesting, will tell us something about our data, and this data can be from intelligent systems or others. Okay, so let's start. To give you a brief introduction about me, I'm a professor in the Big Data Center at Shenzhen University. Shenzhen is a big city in China. It's just beside Hong Kong. It is about 15 million people. So I work there. I'm Associate Editor-in-Chief of Applied Intelligence. I'm a national talent in China. And we do research about data mining, how to analyze data, especially pattern mining. That means to find patterns in the data, as I will talk to you today. So about the design of algorithm to analyze data. So now let's give a brief introduction for this talk. Okay, so nowadays we talk a lot about artificial intelligence. We want to build some intelligent systems. For example, intelligent systems for education, for healthcare, and many other things like telecommunication, industrial systems, and so on. So all of this is important, but if we want to build the intelligent system, most of the time we need to have some data. It could be some data to have some knowledge base, to build some kind of knowledge base system, okay, to do some task. Or it can be to train these machine learning model, for example. So in this case, maybe we need a lot of data to train the model and so on. So getting this data is important, and we need to have the good data, of course. And also, not only this, but all these systems, intelligent systems, will produce a lot of data. It could be the data about the usage, how the people use the system, the log of the system, like errors, alarm, and so on, or the sensor data, the data received between different systems that interact with each other, and so on. Okay, so data is always very important. So now, if we have a lot of data, nowadays we have a lot. We always talk about the big data and so on, especially in the industry. So if you have big data or a lot of data, and what can you do with this data? If you just have data but you don't know what to do, then the data is useless. Okay, so having a lot of data is great. What can you do with this? So if you want to do something, maybe like prediction and so on, of course you can use this data. You can, for example, use machine learning to build some model based on your data, and then do prediction like recommendation or other things. Okay, so all of this is great, and nowadays we have some very good machine learning model, like for the deep learning and so on, very accurate. But there is one problem about this. Many machine learning models are like some black box, actually. Okay, so you give them some input and it will produce some output, but as a human you will not understand why it works. It will give you good result. With your data you have a model, a good model, but why does it give the good result? Maybe you don't know. Okay, so it is more like a black box many times. Okay, so if we want to understand more about the data, we can also use other techniques, other types of techniques. Okay, so today I want to talk to you about pattern mining. It is a subfield in data mining where the goal is to find patterns in the data that are interesting, will give you some knowledge about the data, and hopefully they are more interpretable by the humans, can reveal something, give you some insights about your data. So there are different types of patterns we can find in data. I will show you some later. Like what we call the item set, means a set of items, okay, or symbols. So for example, for shopping, an item set can be the people buy the bread and the milk together, and so on, okay. So finding some correlation between this value in your data, like people like to buy some products together, can be interesting. It can help you to understand. Some people, they like to buy these together, okay. Maybe we should do some marketing, or we should investigate more about this. Other types of patterns could be sequential patterns, like a sequence of events, or some kinds of rules, as I show you on these slides. So here I found a rule in a computer network, okay. It says if there's a fault in computer A, 60% of the time shortly after, the computer B will shut down, okay. So again, this is something interpretable. If there's a problem in this computer, the other computer will have a problem. So then we can fix the computer A to avoid the shutdown of computer B, okay. So the goal in pattern mining is to find patterns in the data, some correlation, associations, and so on, okay. Okay, so what kind of data we can analyze? There's a lot of types of data, like graph, text, or spatial data, sequences, or time series, and so on. Today I will give you some example about shopping, because it is easier to understand, but we could apply this to data from intelligence system or other types. So I will take a simple example here, where we have a database about the transactions from customers in a store, okay. So let's say we have a store, and we have 5 products: apple, bread, cake, dates, and eggs. Here I have a transaction database, the table here you can see. It has 4 transactions that have been made by the customers. So the first transaction, for example, means that someone bought A, B, C, D, E. A for apple, B for bread, C for cake, D for dates, and E for eggs. So we have other transactions like this. We have 4. And if we look at this data, we can do use some algorithms, and we can find patterns in this. For example, we could find that everyone buy the apple always buy the bread. A, B, A, B, A, B, and so on, okay. So this is a little bit what we want to do. We want to find patterns in the data, can tell us something more about the data, okay, hopefully. So if we want to find patterns, how can we do? I will give you the brief idea about this, okay. So you can observe that there can be millions of patterns in the data. For example, we could buy apple with bread, apple with cake, bread with cake, bread with eggs, bread with cake and eggs, and so on, okay. There are many combinations of items someone could buy. So if we want to find the interesting patterns, we need to define what it means interesting for us, okay. So for example, we could find the pattern using some measures, like the support. Support means how many times. So you want to find what the people buy many times together, for example, with the support. Or the utility. Utility means like the money. You want to find what the people buy makes the most money, okay. So this is another goal, it's different. So first you need to think what you want to find, what kind of pattern. Then you choose some measures like the support, the frequency, or the utility like the money, or other things. So after this, after we know what we want to find in the data, we can choose some algorithm to find efficiently the patterns that we want to find. So it becomes some enumeration problem. Okay, you have some data, you know what you want to find, and you need to design some efficient algorithm or use some algorithm already designed to find these patterns. Okay, so this is what I do in my research. So let me give you some example about this. I will talk to you about a classical problem called the frequent pattern mining. In data mining is a very traditional problem, and then I will show you some new problems, okay, and some new results also to show you some trends about this. And I will explain how we could use this with AI and so on. Okay. So frequent pattern mining is a traditional problem proposed about 30 years ago. The input is a database of transactions, like I showed you before, and we need to set a parameter called the minimum support. That means the minimum frequency. And the goal is to find some frequent item sets, some sets of items, let's say, that people buy many times together in the data. So let me show you this with an example. Here I have an example. I have a database on the left, the same I showed you before. And on the right, I have some frequent item sets. So if I set the minimum support to 2, I will find several item sets like A, AB, ABD, and so on. So we say that those are frequent item sets because they appear at least twice in the database. So as the user, we have data, we set the parameter to 2, for example, and we want to find everything appear at least twice. So for example, ABD appear twice, so it is at least 2. We have ABD, and also we have ABD here, so 2 times. AB appear 3 times, so we have AB, AB, and AB. Okay, so it is also frequent item set. So this is very classical problem. So how can we solve this problem if we want to find the frequent item sets? So there is a naive approach or simple approach. It is to scan the database, read the database to count the frequency of all the possible item sets. So for example, we could have A for apple, apple and bread AB, AC, AD, AE, ABC, ABD, ABE, BC, C, CD, CE, ABCDE, and so on. Okay. So as you can see, there are many possibilities. If you have only 5 items in your database, then there will be, let's say n is a 5, okay, 5 items. There are 2 to the power of n minus 1 possibilities. So for 5 items, it means 31 possibilities. Minus 1 because we want to remove the empty set. Okay. So now if you have a big store, okay, with more than 5 items, let's say 500, this is the number of possibilities. It is very big. So to find the solution to this problem, we cannot look at all the possibilities in the search space. We need to have some other approach to find the solution quickly, to design the good algorithm. So I need to say that in this problem there is always one solution. For the data, the parameter as input, there only one solution. So the goal is to find the solution quickly. So how to design a good algorithm? I will just give you the intuitive idea about this. Okay. So there is a very famous property we can use to solve this problem. It is called the Apriori property or anti-monotonicity. It says that if you have 2 item sets X and Y, x is a subset of y, then the support, the frequency of y, must be less than or equal to that of x. Okay, so let me show you this with the example. Okay, I have again the same database, and here I look at AB, apple and bread. It appears 3 times in the data, AB, AB, AB. So the properties say if X is AB and you have a superset like ABCD, you know that ABCD cannot have a support that is more than 3. Okay, so if AB appears 3 times, the superset of AB, like AB with something else, like ABC, ABCD, cannot appear more than 3 times. So why is this interesting? Because it can help to reduce the search. So if you know that AB appears 3 times, but you want to find the item sets appear at least 4 times, then you know that anything that has AB cannot be a frequent item set, like ABCD, ABDE, and so on. Okay, so you can save a lot of time to find the results. So this is a classical problem. Okay, this is just the basic idea how to solve the problem. Now I want to talk to you about some new problems, okay, that the researcher work on these days. So frequent pattern mining is very useful, but it has some limitation. First, many frequent patterns are not interesting. For example, maybe we find that many people buy bread and milk, but bread and milk, it is not something very surprising, okay, and also it does not make a lot of money. Maybe even the store will lose some money when selling the bread and milk. Another thing, another limitation is that we don't have the quantities, okay, either we buy the bread or we don't buy, but we cannot say we buy 5 bread or 10 breads. And also all items are considered to be equally important. So if you sell 1 bread or you sell 1 computer, it is considered to be the same in this problem. But of course, if you sell a computer, you make a lot more money, okay. So to address these problems, it has been proposed a new problem called the high utility item set mining. I would like to explain to you. So it is a generalization, a more general problem, where the items can appear more than once. Like we can buy 4 bottles of milk or 5 bottles of milk. And also the items have a unit profit. Like if you buy a bottle of milk, it will make $1 profit and so on. And then the goal is not to find the most frequent pattern, but to find the patterns that have a high utility. Utility, for example, means money, okay. It could mean other things also, but here I use the example about shopping today, okay. So using this, we could find the patterns like caviar and wine that make a lot of money, but maybe are not frequent in the data. Maybe they are, maybe not, okay. But for the business manager, find something make a lot of money, maybe more interesting than the frequent patterns, okay. So let me show you how this works very quickly, then I'll show you more recent approach for this. Okay, so high utility item set mining, the input is a transaction database again, but it is a little different from what I have shown to you before. So here we have a database. For example, the first transaction, we have the quantities, okay, 1 apple, 5 bread, 1 cake, 3 dates, 1 egg, and 5 F, okay, and so on. And also, beside this, we have a table on the right with the unit profit. So what does it mean? For apple, the unit profit is $5. Means if you sell one apple, you earn $5. If you sell one bread, you earn $2, and so on. Then in this problem, the user needs to set a parameter called the minimum utility. That means, for example, minimum amount of money. Okay. Now the result, the output, will be all the high utility item set. The item set make at least more money or equal than the minimum utility. Okay. So for example, if I set the minimum utility to $33, I will find the 4 item set you can see here. BDE has utility of $36, BCD $34, BCDE $40, and so on. Okay. So this is the problem. But how do we calculate the money? Okay, let me explain more about this to you. So how we calculate the utility or the money in this case? So let's say we take an example. I want to find the utility for BDE together. So it is important to say this is BDE when the people buy them together, bread, date, and eggs. But they cannot be separate. Okay, they must be together. So to calculate the utility of BDE, we look for the transactions that contain BDE together, like BDE, BDE, and so on. So here we have 5 bread for $2 each, so 5 multiplied by 2. Here we have 3 bags of date for $2 each, so 3 multiplied by 2. And here 1 egg for $3. Okay. Then here we have 4 bread for $2, 3 dates for $2, and 1 egg for $3. So the total is $36. So this is the idea how to calculate the money. Now, why this problem is interesting? For the researchers, this is a difficult problem, not easy to solve, because there are many combinations, but also, unlike the frequent pattern mining I explained to you before, the utility is not monotonic or anti-monotonic. Means we don't have the nice a priori property to reduce the search. Okay. So let me show you this with our example. So if you have BDE make $36, you look at the superset like BCDE or ABCDEF. The money can be more or less. So BCDE, if you add C, it can make more money because you buy more things, okay? Then maybe it makes some more money. But in the case of ABCDEF, it makes less money. Why? Okay. So maybe you want to know why. So there's a reason. Because ABCDEF, you buy more things, but there are less people that will buy all these things together. Okay. So the money will decrease also. So because of this, we cannot use the frequent pattern mining algorithm to solve this problem. So how to solve the problem? Briefly, there have been many algorithms for this. These are some of my own algorithm here also in green. So the key idea, the utility don't have the good property to reduce the search, but we will find some upper bound on the utility of item sets that will respect the a priori property and will help us to reduce the search. So this is the key idea in these algorithms. Actually, all these algorithms have the same input and output. The only difference will be the optimizations, the data structures, and so on. Okay. So all of this is useful, but what about the time dimension? Okay. So in the previous example, as you can observe, there are no time. We don't care about the time. But time in the real life is important. Maybe the customer behavior can change over time, or the behavior of some system, okay? Some items may become more or less popular, and there might be some other regularities in the data that we can observe over time. So let me show you some extension if we want to add the time to this. So in a paper we did a few years ago, we tried to find the recent high utility item set. That means the sets of products that recently made a lot of money in a store. So here I show you, for example, a picture. We have the time and we have the utility. So let's say this is for products like the apples. We can see that the utility maybe will change over time. Okay, so here of course is not the real data. I just draw this, but it is to explain. Okay, so we want to find the item set recently, let's say the last week, the last month, has made a lot of money. So we design some algorithm for this, and we use a decay function to evaluate the importance of the time. So if something happened recently, it will have more importance and so on. Okay, so let me show you more. Another topic we can do about the time is to find what is called the concept drift. In data mining, what is a concept drift? It means the data over time, there will be a change in the data. The distribution will change and so on. So we did a paper about this where we look at the utility, the money, for example, of products over time. And let's say here I have a small example for you. A drift will be when there is a change. It can be a big change or more gradual change, but there will be a change over time. So we want to detect these changes. So for example, let's say this is for apples, okay, this picture, and at some point some people on the television say these apples are so good, we should all buy these apples. So a lot of people start to buy the apples, and there is a big change. So how to do this? We design some algorithms. We use a sliding window, two sliding windows, and we do some statistical tests to see if the utility has changed between two windows over time. And we try to find the changes that are significant in terms of statistical test. Another topic we did about the time is to find the peak high utility item set. So we did this in another paper. So what is a peak high utility item set? Let's look at the picture here. So nowadays I work in China. In China, during the Mid-Autumn Festival, it is a period of the year, the people like to buy the moon cakes. Okay, it is some cakes that people like to eat. So if you look at the utility of this product over time, there will be a big peak around the time for the Mid-Autumn Festival. A lot of people will buy this. So we designed some algorithm based on the moving average crossover to detect the peaks that will appear in the data to find this kind of things. Okay. There are also other ideas we can use when we look at the time in the data. We can try to find some trends, like the increasing trends, as you can see on the picture here, or some decreasing trends. So automatically we can find the time interval where there are some increasing or decreasing trends in the data and report them to the user. So this can give us some insights about the data. But of course, after this, we could investigate more to see why there's some increasing trends and so on. Another interesting topic about the time is to find the periodic pattern. Periodic means something always repeat over time. Okay. So for example, we could find some people like to buy the bread and the cheese every week, every weekend, okay, always. So this is a periodic pattern, maybe repeated always over time, okay, many times. It could be every week, every day, or every month, for example. So this type of pattern also very interesting, because we can use maybe to understand about the customer, or to do some recommendation maybe, okay. If we know you always buy some products every week, we could send you a message on your phone to remind you to buy again, or to give you some discount or other things maybe, okay. There are also some other paper we did for the periodic patterns. We try to find the stable patterns. So let me explain what does it mean, okay, briefly. So stable means that the pattern will always appear at more or less the same amount of time, okay. Let's say more or less every week. But it will not change a lot, okay. Always about every week the customer will buy the products. But sometimes the patterns can be unstable. Maybe every week the customer buy, but then he don't buy the products for 1 month. Then he buy every week. Then he don't buy for 1 month, and so on. So we designed some algorithm to focus on the stable patterns. So I will not explain the details about this, okay. Here I just want to give you some overview about different things we can do, okay, with time. Also, another topic not related to time we did recently is to find what we call the cross-level high-utility item set. So the idea is you have a database, as I showed you before, with the money, okay. But now also we have a taxonomy, like an ontology, okay, a taxonomy. So taxonomy means, let's say you have a store. All the products in your store are organized into some categories. Maybe you have a category like the computer products. So in computer products, you have mouse, keyboard, computer, and so on. Maybe another category in the taxonomy is the dairy products, like the milk, the cheese, and so on. Maybe also you have different types of milk, okay. So if we have a taxonomy like this, we can find the patterns with these categories, like Z and X, okay, could mean any kinds of milk with any kinds of cheese make a lot of money. So this is interesting because it is more abstract, okay. So let me show you some example from real life. We use some public data and we use our algorithm called TKC. We analyzed the data from a store in the US, and we found that many people like to buy the beans with the cherries. So here, beans, it is a category. There are different types of beans, like the baby beans, the green beans, the broad beans, and many others, okay. But generally, you don't need to know what type of beans. Any type of beans people like to buy with cherries in general. Maybe there are some exceptions, but it is an important pattern in the data. We also analyze other data from a liquor store in the US. We find other patterns between the wines and the alcohols also. Okay, this is another topic. Okay, another problem, to give you some overview about some recent problem, is to find what we call the cost-efficient patterns. So we want to find the patterns that have a high utility, like make a lot of money, but have a low cost also, okay. So let me explain this briefly to you. here on the left, I have a database about the hospital. So I have 4 sequences. Each sequence is a set of treatments that people take at hospital when they are sick. And the utility means the benefit, like the people are cured or not from the disease. So let's say the first person has a treatment A. It costs $4. A treatment B, $2, and so on. And positive means the person is cured from the disease. Now from this we can find the patterns to find the best treatment that will get you cured and will not cost a lot of money. So it will be cost efficient. Okay. So we did a paper about this. Again, I will not show you the details. If you are interested, you could have a look, or we could talk more about this. Okay. But today I just want to give you some overview about some things we can do with pattern mining. So there are also other types of data we can analyze, like the graph, for example. Here I will skip the details, okay? But if we have a database of graphs, we could find some patterns that appears in these graphs, for example. So we have algorithms also to analyze the graphs and so on. So here I will skip the details, okay? So what are the challenges in this field about pattern mining? The main challenges, I think, are to design the more efficient algorithms. We want to have new strategies, data structures. We want to use the GPU, multi-thread, or big data platform to deal with more data, to be more efficient, because some of these algorithms can take a lot of time to run. Also, we want to handle the more complex data. The data I have shown to you today is still simple. Maybe we have more data, more precise data, more information about the people who buy the products. So, if we have the more complex data and we can handle it, we can find the better patterns, and also the more complex patterns may be more practical in the real life, okay? More chance to be used in real life. And also, we can look at new measures to select the patterns, not just the money or the support and so on. We could find other types and also design some new applications. Some trends that I observe in recent years are to find the patterns that are statistically significant using the statistical test. So this is a hot topic, okay? Also find the patterns in the data stream and in the graph or the sequences. These are some popular topics these days. Now, as I told you in my introduction, in pattern mining, our goal is to find mainly the patterns that are maybe can reveal something to us that will be interpretable, okay? So, and I told you, some machine learning models are more like a black box. So we could try to bridge the gap between pattern mining and also machine learning. Maybe, I know some people, they use pattern mining to explore the data, to do the feature engineering for machine learning. So I was talking with some big company in China, and they use some pattern mining techniques to explore the data. So if they find some association between some values, it can give them some insights about which attributes are correlated, maybe. Okay. Also, we can use the data from intelligence systems to find patterns or to build some intelligence systems. So in my PhD, for example, 10 years ago, I was doing e-learning, and we find patterns in the what the humans will do, and we use these patterns to build intelligent agents that will use this pattern to explain some tasks to the students. Okay. Also, Another topic is to use the patterns to make the embeddings for the machine learning and so on. There are a few papers about this. It is an important topic. And also we could use machine learning to find the patterns also as well. So if you are interested by this, by the pattern mining, I am the founder of a software called SPMF. It offers nowadays more than 240 algorithms. It is in Java, open source. You can use as a standalone program and also include in other software. There are also some wrapper for other programming languages. Okay, you could try on your data. It is really easy to use. The interface is super simple because my goal is to give algorithms. It is not to make a very complicated software in terms of user interface. Also, I want to say we have a few books about pattern mining, like the high utility pattern mining, the periodic pattern mining, published by Springer, and also other topics. And also every year we organize the workshop at ICDM or KDD about the utility mining and machine learning also. Okay, so if you are interested, you could submit some papers. And also we have a workshop at PKDD about the machine learning in software engineering. Should be back again this year also. So that's all for my presentation. I wanted to talk to you about pattern mining, how it can be used with AI, especially also for intelligence system. And I want to show you some new topics and talk to you about some trends and challenges. I hope it has been interesting. If you have any questions, I will be happy to talk with you about this. Thank you.